Hello everybody, my name is Conrad and today I will show you a little bit how you can prototype really fast with replikativ in Clojure and Clojurescript. So I thought that it would be nice to have just a simple prototype, so I would go to build an app that just captures your working time. So you have a project, you have a task, and it took a certain amount of time to do this task. So that's the promise, and I want to build this app really fast without too much hassle. And I will show you how you can do that with replikativ. So let's have a look. I've already built a basic skeleton for the project. So I've just used the standard lining template and thus just added some basic files. So here you can see we have a basic Clojure CLJ file. We have some styling I actually use in some of my projects. We have a backend file and a frontend file, and just an index file. So let's have a look at that first. So we have the basic project files where we have just basic dependencies we are using, in this case the latest Clojure and Clojurescript version, the latest replikativ version. We will be using Ohm, the React wrapper for Clojurescript in the latest version with Ohm Next. We will use Sablono as templating library. We will also use for the backend HTTP kit to serve the HTML and the assets. And we will use Composure for the routes, and all the other stuff is just boilerplate. So we have some plugins, we have Sass for styling if we want to do that later. Yeah, just basic builds. So we will using Figwheel as our fast building block. Alright, so let's have a look at the core file. That's the backend. So we will now write all the server code we need to build the app. And okay, let's have a look at the requirements here. They require, so we will use hash for the UIDs. We will use the server peer of replikativ. We have to use Cabal as ours with start and stop services for the server peer. We will use just an in-memory store in this case, because for the fast prototyping it's not necessary to have a durable store at the moment. Maybe in the next screencast I will add that, but for this cast I will just use these one. So the next one is super v async. That's a library that adds a better error handling to the Clojure core async. And we will use HTTP kit as a HTTP server and the routing. So let's just start. We will use a predefined URI for the server. So we will connect all our clients with WebSockets. So we just say, okay, it's localhost in this case, because we something like this. And then we say, okay, it's now we define some routes, dev routes. Some base routes. So that's resources is just the base. And then, because it would be nice, we just use a not found route, and then we say, yeah, 404 not found, or page not found. That's the basics. More, we don't need more for the server. So now the interesting part is the replicative part. So def and start server. Let's wrap this in a function. We need two things for replicative. We need a store. In this case, it's just the in-memory store from Conserve. So new mem store. And if we add it, we can just we should just start a REPL in the background while we code. So then we have a peer. That's the server peer we will be connecting to. So this uses store again and URI and our async supervisor. Yeah, I won't use a special one. I just use the default supervisor. Then we will start the HTTP server with the base routes. So we have base routes, and we will just use a basic port. So in this case, port 8080. And yeah, that's for the first part. Let's see. The REPL is started. So let's see. Let's give a print line here. Print line. Server started. HTTP server started, and then we have to start the replicative stuff. So first we start the peer. Start peer. And then we will just block the execution. So okay, that's it. That should here. Yeah. My bad. Yes. Alright. And that's all we need in the backend. It's pretty much to nothing. If you compare this to for instance a REST service to synchronize the state between clients. That's a real mess, and I do this on my day-to-day business, so that's something different. So let's see, comment. Yeah, we will start the system server later. So okay, that's that. And now I will start with the front end. So let's see, Clojurescript. Here again, I will just start a new REPL, and while this loads up, I will just tell you something about the libraries. Here again, we use an in-memory store in the web app. We use a client peer. The difference between client and server peer is that server peers can can provide sockets, while, as you know, in the browser you can't open sockets other peers can connect to. So this then we have the replicative stage where we will commit our data. We have hashcore for the UUIDs. We have as our confluent replicative data type, we have an OR map, an observable remove map. Where we get our stage and our functions to interact with the local state. And then again we have async and super v async, and we use next as our primary rendering framework, and we will just use Sublomo as templating, and that's it. Okay, I'm seeing here we have a REPL already. That was fast. Yeah, that's nice. It's really faster than my laptop. So let's see. Enable. Oh, enable. Let's see. Enable console print. Let's see if this if the REPL works. Let's see. Let's just set an alert. So what JS alert? I think. Hello. Yeah. Yep. We have a REPL. Okay. Okay. So here again we need some boilerplate for the replikativ connection. So first we define some basic user. So we have Alice at Clojure, for example. Then we need some UUID for the OR map. Yeah, we will create that in the backend. So we just use Java util UUID random UUID. Yep. Okay. Here we have the UUID. Let's evaluate everything. Alright. So the URI will be, what was it? Oh, let's copy this. Simply copy this. We want to be fast. Alright. So first we will have one central well item, which will be replicated to all other clients. So let's define that. We have def once the well item, so that's central, and as I said, we want to have some captures, some captures which will be just a set of some hash maps. And yes, that's our core data structure. Okay, so we need to set up replikativ first. So let's do that. Let's say, okay, go try our supervisor again, and then we will just see how we can do that. First, we need again a store. Yep, we need a store, and which will be our new mem store. Then we need a peer, a client peer. In this case, needs the supervisor and the cold store in this case, and that's our store. And that's it. That's these two things. So that's the connection with the server. Now we have two peers connected, speaking with each other, and it's stored in the mem store. Now we have a stage where we operate on. So let's create one. Create stage, user and peer. And we need, in this case, as internally the replikativ state is quite different than the state we are working on, so we have to stream the actual data we need into our well item. In this case, we will just stream them and applying some functions. So stage, user, and the ID. Then we will have some. We will need some stream eval functions. I'll define them later in a moment. And we need an identifier. In this case, identifier. We need an identity. In this case, it's the well item. So stream eval functions. Let's define them. Stream. That's just a hash map of the functions we will be using. So associate and disassociate, as we are operating on a OR map. So first we will just say, okay, this we will get our well item and a new value in this case, and then we just swap the item, and we will update in this case captures, and we will just add the new element, and then we should return the item. So if we remove something later, or maybe better, we just call them add and remove. Maybe that's better. Yeah, that's better. Okay, and then we remove an element, and we say, okay, swap our item, update in captures, and then we just remove it. Let's see, remove a new element. Oh no, it's an anonymous function. So let's see, the old element. The old remove new from old. Okay. Yeah, and then we just return a. Oh, let's see if this I can't always remember which returns what. In this case, remove. Let's see. Is this a list? Let's see. Nope. One from 1, 2, 3. Yeah, I like this about Clojurescript. I can just use the REPL and just evaluate inline the stuff. So we have to make a set out of this. Okay, so remove new old. Yes, this should be enough. Okay, that's the stream eval functions. Okay, so the stream is done, the stage is done, peer and store. We have everything set. Now we will have to create our OR map. So in this stage we say create OR map. Stage with the description. In this case, captures this way, and the ID must be our OR map ID we defined earlier, and that's it. Now we are set. Now we can connect our stage with a URI, and the server should send all the updates we need. And for convenience, we just return all the elements we have here. In this case, the store, the peer, the stage, and the stream. So stage, stream, and what's missing? The peer. Okay, and that's everything we need to just connect to a server. So we don't have to map REST endpoints or anything else. Just Just this little code, and that's really nice. Okay, and everything in this will be just store. So we have actually we have two states. One state is just for the data we will be presenting in the web app, and the other one is just the replicative state. And in this case, the replicative state is just this hash map stores stage, stream, and peer, and we just store this in the, let's call it replicative state. Okay. Exactly. Now we will adjust the function that abstracts the transaction itself. So we say, okay, add capture. What we want is here our state. In this case, the replicative state, and a new capture. And then we just say, okay, in the stage we have an OR map, and we want to store a set. So we just use a little trick. We just say, okay, we have a key as keys. We will use the just the hash value of the new data we will be receiving. So let's associate in this stage state, and let's just say what I can't remember. Stage user OR map ID key on transactions. Stage any user OR map ID. We will have the key. In this case, we will just use the hash of our data, and the value will be just add and the new data. So every time we transact something into our stage, these elements will be added and will be distributed to the other clients if they are there. And okay, that's it. That's all we need for the replication. So it's not really much. So that's nice. Okay, now for the interesting part. Maybe we could just start. We just could start the system. Yeah, let's first I can't really remember how I started the index. Let's have a look. Yeah, it's just a basic index HTML. So we have just some style CSS, some nice looking font, title, and so on and so forth, and we're starting it with the main function. So we will just add this def main. We have some arguments. In this case, I think we don't need anything. And now it's the interesting part. We will have the connection to the server peer here. So it's here setup replikativ. That's it. That will start the connection. Now we just say error JS console and Stech was started or connected. Okay. Connect. Oh, there's some error. Yes, there. Let's have a look. Console. Ah, okay. Field not found. Of course. Of course, there's nothing there. We have no backend running yet. So let's do this first. Start server. Oh, yeah, always these typos. So now Oh yeah. Okay. Now, base routes, run server. Okay. Let's start it. Okay. Server peer started. Let's restart the client. So now we are connected. So we have here the intro the first connection, and then the client peer will connect to the server peer, and then they will exchange the data. So we can see here starting subscription and so on and so forth. And now we can do stuff. Now it's from now on we will never have to think about anything that is related to server stuff. That's really nice. We don't have to think about, I don't know, REST endpoints or anything but like that. We have just to operate on the well item, and then it's all fine. Okay, so let's start with the entry point. So we will just use the basic next structure. So we will say render this, and we will just say HTML and then h1. I don't know, time captures or task captures or something like that. So let's see. Why is it not work? Oh, of course. Yeah, we'll have to add the reconciler. So let's say okay, reconciler. Yeah, we have to add the route at the root of the React app. So it's recon. Yeah, here reconciler. That defines the state, and in the future, when we will extend this app in some of the next screencasts, we will just add the well item. That's okay. That's also okay. And we have to add the root. In this case, it's here. We recon. I like this reconciler. In this case, the app. And we need get element by ID, JS document, app. And that should, there it is. Here we have the first element, and from now on we can just extend around this stuff. Okay, so now let's add some input. First we have to think a little bit about it. What do we want to capture? We want to capture which project is we worked on, which task, and for how long. So we need 3 input fields, and I think they will be all the same. So let's just define them in a function input widget, which will receive the component in which it will be built, and the key of the local state, because I think, in my opinion, it's better to store the actual input state in the local state of the component. I don't want to pollute the global state with this stuff, because it changes so fast, and it's not yet necessarily useful data. So and we don't need to distribute this, so that's fine. So let's say we have some input which has a value, and the value is of course in the local state, I think, of the component. So local key, that should be enough. Yes, yes, and the value is at, oh, yeah. Let's add a placeholder so we can see what's actually about. And then we, of course, we need an onChange function. And in this case, we just say, okay, this will be just a function that captures that's triggered by the onChange event, and then we just update the local state. So that means we just say, okay, update state of the component, and we just associate the local key with let's see, that's better maybe, with the target value. So it's target and it's value, maybe value. That's part of the stuff I can't remember always. So input widget, this placeholder will be project, and local key will be input project. So we have to add we have to set the local component state first. So that's React stuff. So this function, the component will mount function, will be called before the component is rendered, and that's the place where you want to initialize stuff. So component will mount this, and then we will just say set state this, and then we have all local state, and in this case it's in hash map. We have project, input task, and the input capture, and let this be all strings. That's fine for the moment, I think, and we might add this later on. Two past two. Oh, okay. I forgot. Let's see. Let's wrap this in a div. Is this better? Yeah, better. Okay. So let's add this project task capture. Okay. Okay. I see. Input task. Exactly. So if you have any questions about what I'm doing, just leave a comment or write on Jitter. I will add all the links and all the stuff you need to know in the comment section, in the description, and especially for replikativ, and also I will add I also created a GitHub repo for this project, and I will just add the code there. So it's input task, input capture, and all right then. So now we have all the input we want, and now we have to add it to the state. Let's see. Maybe so. This it's basically I'm using a little bit of my own styling and CSS, but I'm not good at this. So it's I'm no designer. That's not what I'm used to. So if any one of you want to like to add something or to help me make this look better, you're free to help me. So it would be nice, so we can do it together. All right. So now we have to add the button that that makes the transaction into the replicative stage. So in this case, okay, we have a button, we have an add button. I hope so. Yes. And we just say on click, and on click is just some function. I think, do we need this? No, I don't think we don't need any events in this case. And we just have to get the local state. Is it anywhere? Nope. We don't have this. We didn't have. Oh, did we? No. No, we didn't. Let's see. Ah, here I have a typo. So what do we need? We have to destructure the local state, in this case input project, input task, input capture. Oh, n'est-ce pas? Okay, so it's get state this. Okay. Okay, so now we have the new capture. That's basically it will be really simple. So task is no, not task. So this way, input task, and capture will be input capture. Yes? Yes. Okay. And then we will just add this to the add capture. And what did we say here? We need just the replikativ state and the new capture. And that's it. That will update the stage and send all the updates on this updates in the replicative state to the server and respectively to the all other clients. Okay, and now we have just to clean the local state. We say update state this, and then we say okay, input. What is this project? Needs to be empty, and we will say we will do this for all three things. Maybe I will clean this up, but for the moment it's faster this way. Input task, project, and capture, and that's it. Now when we add something here, for example, we have this task here. This project, the task is create basic backend or basic replicative backend. And we will say, okay, this setting up the backend is with all the boilerplates is 5 minutes or 10 minutes. And we will say, if we say add, then you can see something happened. Replicativ received the update and processed it, and then we have the data everywhere. So let's have a look if it's really in the well item. So let's say well item deref, because it's an item, captures. Oh no, here it's there it is, project blah blah blah. Okay, cool. And now we want to see this list. So what do we do? We will add another element in the HTML. We will just say okay. Now we have a second widget, as I call them, this, and this should be some form of a table. Do we want headers? Yes. Table row. Table header, it's project. We want to know which project it's in. We want to know which task, and we want to know the time or the capture. And then we just want to have just the list of type captures. And for that we will just get the local state. So basically we are using onNext, but just for simplicity we will just use the plain old React properties, and in this case we will just captures just destructure the properties and the URL item that is given to the component. I think later on I will, or in next week maybe, I will just add some more more distinct functions there, and then it would be useful to have the parsing functions from onNext. So something like read and mutation functions. So we could parameterize these things and work with them better. And so we could decouple all the state changes and all the other stuff from the view layer, and that would be nice, really nice. Okay, now we have to map around these captures, and we just say okay, we have this keys project, task, and capture. Every time I want to type catch instead of capture, so I don't know. So in this case it's just a vector of table rows. So we have here table data, it's project. Table data is task. Table data is the capture. And now let's have a look. Woo! It's, yeah. Home next thing. I don't. Table row appears a child of table. I don't think so. Maybe later. I have no time for this stuff. So now let's see what happens if we add another stuff. So now we have the add front end replikativ connection. 5 minutes. And now we have this. And now we're basically, we're finished. That's the first prototype, and it took us not that long to just have this. And now we will test it. Now let's see if we have a second Chrome. Let's see. Let's restart this and look if after reconnection the data is still there. And let's see. Yeah, so we have now 2 clients that is connected with the server here, and we will just say project X task foo, and let's say 42, and here it is. It's replicated, and in this case here Y. Project Y, tasks bar, capture 1, 2, 3, add, and again if we restart here and restart here, the data is still there, and we have nothing to do else. Alright, that's it folks. Thanks for watching, and if you have any questions about replikativ or or my coding style or my Emacs configuration, just go ahead and ask. And again, I will provide any infos in the description of this video, and have a nice day. Bye.